Hello, this is session number 8. We are going to process wide-scan survey spectra. We want to show you the basics of what is done. First off, we need to do any charge correction that might be necessary. We can zoom in on this and get a look at what the carbon 1s value is. It's 280, so it might be nice. It's not necessary to charge correct this by approximately 5 volts. So let's go up and do that. Put in a -5, which shifts it to the left because it's monochromatic. Hit accept. Zoom in again. And what's the number now? 285.2. That's sufficiently accurate for survey spectra. All right, as we look at the survey spectra, we have the carbon, the oxygen. Since we know we've got chromium oxide, we understand this is some chromium peaks. This is chromium peaks. And also down here are chromium peaks. So let's go ahead and find and identify the peaks. Okay, we have found the peaks, integrated the peaks. That's why we have a black line down here. Now what we want to do is select this identify peaks shortcut or spectral lines. It's a pop-up screen. Okay. And what we want to do, put it slightly out of the way. And we'll start selecting the elements that we know are present. For example, we know carbon is present. We could choose number 6, or we could choose the letter C, and then the peaks corresponding to carbon would appear on the screen. We say add those peak IDs to the table, and it does. Now it's got carbon 1s there, carbon 2s down here. You can clear those lines, and then we'll add the oxygen. Now we got the oxygen lines here. There's an overlap here of the oxygen 2s with the carbon 2s, sorry. And we've got the oxygen Auger lines out here. They're highlighted in red. So we can add those peaks to memory. So now we get the labels up above. Finally, we also know that there's chromium in the sample. Since I don't remember the atomic number for chrome, I do remember its abbreviation CR. I select CR, and you get the peak showing up here. And if you need to, you can do charge shift correction here. Okay, as you can see, the peaks are moving. You got a total range of plus or minus 20 volts. Okay, might be handy sometime. All right, we add those labels and we press clear lines. So now all the peaks are labeled except some minor peaks. This chromium loss peak, here's another chromium loss peak. So we can go in and label that one as we please. We select it by just drawing a zoom box around it, and we come up here to the picture of a peak with a question mark above it. It opens, and we say this is a chromium loss peak. Chromium loss peaks and loss peaks in general, I should say loss peaks in general, are about 10 to 15 EVs above the main XPS signal. So that's why you see an oxygen loss peak here. Here's another loss peak. This is from the chromium 3P. So to help the customers or to help the people seeing the data, let's go ahead and add a label for what that is. CROSS, a chromium loss peak. And effectively we're done. What we do, however, want to do is to display the atom percents that go together with this particular sample. And we come up here, we choose the atom percent table. We look over here on the left, and the peaks that we want to use to quantify the chromium 2p3 peak, the oxygen 1s, the carbon 1s, and that's it. There's no other contamination. So we close that. We look over here, and we notice chromium 2p3, that's not right. It really should be chromium 2p, because we have integrated both the 2p3 and the 2p1 together. So let's go back in and fix that. Go back up here to the atom percent table. We scroll down, we double click. We remove the 3, and the sensitivity factor, let's make sure it's doing the right thing. No, must be a typo in the system right now. So we want to add 6.17 to 3.17. So we want 9.34 for the sensitivity factor. So let's put that in. 9.34 is the sensitivity factor for 2 peaks that are related and both integrated together, for especially for this chromium 2p peak. So close. Somehow it missed it, didn't take it. Let's go back in. We'll go this way. We can do it this way also. We should have a 9.34 number there, and we should have a no 3 there, and we hit accept, and now we have a correct label. And if you want to check on these numbers, you come up here to the table again, you scroll down, and a 9.34. Okay. So there are other ways to go about modifying the table and other things you can do with this table, but that's the end of this particular lesson on processing wide-scan survey spectra. Thank you.